The first question says the table shows the areas in kilometers square of the 4 largest rainforests in the world. Find the area of the Valdivian rainforest as a percentage of the area of the Amazon rainforest. So it's the Valdivian rainforest and this is the Amazon rainforest. So that's going to be 250,000 divided by 5,500,000 times 100. And that's going to give us 4.55%. Then it says, write in its simplest form the ratio of the areas of the forest, of the rainforest, Valdivian, Atlantic, to Congo. So Valdivian was 250,000. Atlantic is this, and Congo is 2 million. So what we're going to do is we're going to simplify this ratio. All of these are divisible by 1,000. So when you divide all of these by 1,000, we get 250 is to 1,315 is to 2,000. So first step was to divide by 1,000. Then we divide these by 5. So 50 divided by 5 is 50. Now we will divide all of these by 5 because all of them are divisible by 5. 250 divided by 5 is 50. 1,315 divided by 5 is 263. And 2,000 divided by 5 is 400. This is the ratio of the rainforest in its simplest form. The question says the Amazon forest has 60% of its area in Brazil, 10% in Colombia, and 103% of the remaining area in Peru. So you have to find the percentage of the Amazon rainforest that is in Brazil, Colombia, and Peru. So remaining after you've taken out 60% of Brazil and 10% of Colombia is 30%. So remaining area is 30% in percentage. So 43.103% of that is Peru. 43.3 over 100 times 30% of that. That's going to give us 0.1299. And then if we, for the percentage, $0.1299 is times by 100. So that's 12.99%. So total percentage would be 60% plus 10% plus 12.99%. And that is going to give us 82.99%, which approximates to 83%. So that is the percentage of the Amazon rainforest that is in Brazil, Colombia, and Peru. The area of the Amazon rainforest represents 7/50 of the total area of the rainforest in the world. Calculate the total area of rainforest in the world. Giving your answer correct with an area is 100,000 kilometers square. So once again, Amazon rainforest was 5,500,000. And that's 27/50 of the total area of rainforest. So let's call this X. So X would be 5,500,000 times 50 divided by 27. So when we solve that, that gives us 10,185,100 and 185.19 kilometers square. It is given square to the nearest 100,000 kilometers square. So that's going to be 10,200,000 kilometers square. That is your answer. Census in the world, 60.7 hectares of rainforest are lost every minute. Calculate the total area in hectares of rainforest that are lost in 365 days. Give your answer in standard form. So every minute, 60.7 hectares are lost. So 1 day has 24 hours. 1 hour has 60 minutes. So 1 day will have 24 times 60, which is equal to 1,440 minutes. So 365 days will have 365 times 1,440, which is basically equal to 545,600 minutes. So now we have to find the total area lost in these minutes. So if every minute 6.7 hectares of rainforest are lost, so area lost in 365 days is going to be this times 60.7. And that is going to give us 31,903,920 hectares. You want the answer in standard form? So that's going to be 3.1 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. So 3.1 times 10 to the power of 7. Or let's say 3.19. That's more accurate. 3.19 times 10 to the power of 7. Next part says the Amazon River has a length of 6,440 kilometers connected to the nearest 10 kilometers. The Congo River has a length of 4,400 kilometers connected to the nearest 100 kilometers. Calculate the upper bound of the difference between the lengths of the Amazon River and the Congo River. So since it's talking about upper bound of the difference between the lengths of the Amazon River and the Congo River, that means we will make Amazon River upper bound and Congo lower bound. The reason why both Amazon and Congo are not upper bound is because when we are subtracting and we're trying to find the upper bound to get the maximum value, the one that we're subtracting from has to be upper bound and the one that we're subtracting has to be lower bound. If it was the lower bound of the difference, then Amazon River would be lower bound and Congo would be upper bound. So it's the other way around. So to find the upper bound of Amazon River, first we need to find the degree of accuracy. So degree of accuracy for Amazon, whatever it's nearest to, we divide that by 2. So if it's 10 kilometers, 10 divided by 2 is 5 kilometers. So that means upper bound would be 6,440 plus 5. So that's 6,445 kilometers. Then for Congo, we need to find the lower bound. So for that, the degree of accuracy now is going to be 100 divided by 2, which is 50 kilometers. So lower bound would be 4,400 minus 50, which is going to give us 4,350 50 kilometers. So now upper bound of the difference is going to be 6,445 minus 4,350, and that is going to equal to 2,095 kilometers. That's your answer. If you're someone who's still struggling with upper bounds and lower bounds and how you're supposed to find them in addition, subtraction, or multiplication and division, I'm going to attach the links in the description and above, and you can just click on those and you can find a very self-explanatory example which helps in understanding how to use this. In question 2, it says, on the grid, draw the image of triangle T after reflection in the x-axis. So after reflection in the x-axis, this point will be over here, equidistant from the x-axis. This point will be 3 units over here, and this will be over here. As you can see, the x-axis is acting as our mirror line. So you just plot the points at equal distance from the mirror line, as the original point is. So you plot the points, connect the dots, and you can see your reflection of triangle T. This is triangle T after translation by a vector of -5, -2. So after reflection by a vector -5 and 2, this point over here is 2, -1. So 2, -1 will become -3 and -3, keeping in mind that the translation vector is -5 and -2. So when we add -5 to 2, that becomes -3, and -1 plus -2 is -3. Similarly, this is 5, -3. So 5 plus -5 is 0. -3 plus -2 is -5. Then this, which is 1, -3. 1 plus -5 is -4. -3 plus -2 is -5. So now if we plot our points, -3 is going to come over here. 0, -5, -4, -5. So if you notice, what has happened over is that your triangle moved 5 units to the left and 2 units down, thus giving us the translation of triangle T. Then it says triangle T after an enlargement by scale factor of -1/2 with center -1, 1. Center is -1, 1, and scale factor is -1/2. So what's going to happen now is we're going to compare the distance of each of these points from the center of enlargement. So this point over here, this is 3 units from the center. So since it's being enlarged by a scale factor of -2, that means the size is reducing. Half of 3 is going to be 1.5. So it's going to be at a distance of 1.5, which means it's going to come over here. Now, the reason why it's coming over here is because the scale factor is negative. It's going to be in the opposite direction of the center of enlargement. Hence, if the original shape is over here, opposite to that is over here. That's why this point is located over here once a scale factor of -1/2 is applied to that point. Similarly, this point over here, which is 1, -3, that will be, now this is 1, 2, 3, 4, 1, 2. So now it's going to be 2 and 1. So 2 and 1 is going to be, so horizontal distance is going to be 1 unit and vertical is going to be 2 units. That's over here. 1 unit horizontally, 2 units vertically. Then for this point, this is 1, 2, 3, 4 vertically, 1, 2, 3, 4, 5, 6 horizontally. So horizontally, it's going to be 3 now. So 1, 2, 3, and vertical is going to be 2. That's 1, 2. So now if we connect the points, this is your enlargement after the scale factor of -1/2, and center of enlargement is -1 and 1. You can check if your shape is correct by connecting the corresponding points. If they all pass through the center of enlargement, that means your shape is correct. And as you can see, all these lines are passing through the center of enlargement. Hence, this is the correct enlargement. Remember, whenever the scale factor is negative, your enlarged shape is going to be on the opposite side of the center of enlargement. Part B says a shape B is enlarged by scale factor 3 to give shape Q. Shape Q is then enlarged by scale factor 2 or 5 to give shape R. The area of P is 10 centimeters squared. Calculate the area of shape R. So now, they have told us that a shape P is enlarged by scale factor 3 to give shape Q. So if you write these as ratios, P is to Q is 1 is to 3. Shape Q is then enlarged by scale factor of 2 or 5 to give shape R. That means Q is to R is going to be 1 is to 2 or 5. Now, whenever we have like 3 different things happening and we have ratios, and there's a one common quantity in both the ratios, what we do is we try to make that common thing equal in both ratios. Common thing over here is Q. Q is 3 in the first ratio and 1 in the second ratio. So to make it equal, we have to multiply the second ratio by 3. We will not just multiply Q by 3, we'll also multiply R by 3 as well, because if we're introducing a new term to one quantity, you have to do it to the other as well. So now this is going to be 3 is to 6 over 5. That is Q is to R. So since Q are equal in both the ratios, we can combine it as a single ratio. That is P is to Q is to R. That is going to be 1 is to 3 is to 6 over 5. Now they told us that the area of shape P is 10 centimeters squared. So we have to find the area of shape R. So what we can do is that, if you remember, when we have similar shapes, length of or scale factor being squared equals to the ratio of the area of those shapes. So in this case, since we're trying to find the area of shape R and we have the area of shape P, length of P over length of R being squared is equal to area of P over area of R. 1 over 6 over 5 being squared equals to 10 over AR. So that is 1 over 36 over 25 equals to 10 over AR. AR equals to 10 times 36 over 25. And that is going to give us 14.4 centimeters square. That is the area of shape R. Remember, when you have mathematically similar shapes and we're trying to find the area, what we can do is we can square the scale factor, or like the ratio of the lengths. Over here, the ratio of the lengths are 1 for P, and for R it's 6 over 5. So 1 divided by 6 over 5 is being squared, and that equals to the area of P divided by area of R. And since we have the area of P, we can substitute that, and the only unknown is area of R. Solve your fractions, cross multiply, make area of R the subject, and you find the value, which is 14.4. Question 3 says C equals to 104 x times y squared. Find C when x equals to 5 and y equals to 8. So C equals to 104 times 5 times 8 squared. And that's going to give us 80. Then find the positive value of y when C equals to 15 and x equals to 2.4. So 15 equals to 104 times 2.4 times y squared. That is going to be 15 over 6.5 equals to y squared. Square both sides. And y equals to plus minus 5. Since it says a positive value of y, so y would be 5. Since it's write as a single fraction simplest form, 4 over x minus 1 minus 3 over 2x plus 5. So first we're going to combine this as single fraction. Whenever we are adding or subtracting fractions with unlike denominators, the first step is to make the denominators equal. To make the denominator equal, the first fraction is multiplied by 2x plus 5. You will not just multiply the denominator by the number, but also the numerator. Second fraction multiplied by x minus 1. So now what we have is 4 times 2x plus 5 over 2x plus 5 times x minus 1 minus 3 times x minus 1 over 2x plus 5 times x minus 1. So 2x plus 5 times x minus 1. So 4 times 2x plus 5 is 8x plus 20. And this would be negative 3x plus 3. So combine the like terms. So that's going to be 5x plus 23 over 2x plus 5 times x minus 1. And that is your answer. Expand and simplify. So expanding triple brackets, first we expand the double bracket, which is 4 minus x whole square. So 2x plus 3 times 4 minus x times 4 minus x. That's going to be 4 times 4 is 16. 4 times negative x is negative 4x. Negative x times 4 is negative 4x. Negative x times negative x is positive x squared. So 2x plus 3 times x squared minus 8x plus 16. So now we expand these two brackets. 2x times x squared is 2x cubed. 2x times negative 8x is negative 16x. 2x times 16 is positive 32x. Now 3 times x squared plus 3x squared. 3 times negative 8x, negative 24x. 3 times 16, that's going to be 48. So we once again combine the like terms. 2x cubed comes as it is. Negative 16x plus 32x is positive 16x. Positive 16 minus 24x is positive 8x. Then 3x squared is, can't be on its own. This is 16. Negative 16x squared plus 3x squared is negative 13x squared. 32x minus 24x is positive 8x and then positive 48. That's your answer. Part D says simplify. So y to the power of 8 over 16x to the power of 16 whole power negative 3 or 4. So first step is to make the negative fractional indices positive. So to make it positive, we're going to take the reciprocal of the fraction. So what will happen is that 16x to the power of 16 comes in the numerator, y in the denominator, and whole power will be positive 3 or 4 now, not negative. Now we're going to distribute the power with each of the terms inside the bracket. So 16 to the power of 3 or 4, x to the power of 16, whole power 3 or 4, and y to the power of 8, whole power 3 over 4. Now we know 16 is 4 squared. 4 squared is 2 squared. So 2 to the power of 2 is 2 to the power of 4. So 2 to the power of 4, whole power 3 over 4. Whenever there's a power outside the bracket, inside the bracket, you multiply the powers. So that means it's going to be 16 times 3 over 4 and 8 times 3 over 4. So that's going to give us 2 cubed x to the power of 12 and y to the power of 6. 2 cubed becomes 8. So that 8x to the power of 12 over y to the power of 6. That is your answer. Question 4 says, Gianni records the time in seconds that some cars take to travel 195 meters. The box on Whisker plot shows this information. Find the median. So median is basically this value. So that is over here in the middle. So between 9 and 8, there are 1, 2, 3, 1, 2, 3, 4, 5 divisions. So that's 1 divided by 5, which is 0.2. So that's 9.3. That is your median value, because it's right in the middle of 9.2 and 9.4. Then interquartile range. This is your lower quartile. This is your upper quartile. So Q1 is 8.2. So interquartile range is Q3 minus Q1. Q1 is 8.2 and Q3 is 11.6. So 11.6 minus 8.2 is 3.4. And in case you don't know, this is your minimum value and this is your maximum value. Find the difference between the average speed of the fastest car and the average speed of the slowest car, giving the answer in kilometers per hour. So the cars are traveling at a distance of 195 meters. And the slowest car is traveling at a time of 6 seconds and the fastest at 13 seconds. So firstly, distance is 195 meters. So since they want the answer in kilometers per hour, let's convert the distance in kilometers. So in kilometers, that's 195 divided by 1,000, which is 0.195 kilometers. 1 meter is 1 over 1,000 kilometers. 1 kilometer is 1,000 meters. So now slowest car time is 6 seconds. So 6 seconds in hours, it's going to be 6 divided by 3,600, which is going to be 0.00166 for Bahrain. That is hours. Fastest car time is 13 divided by 3,600. This is in hours, once again. So now 13 divided by 3,600 0.00361. Now we have to find the difference between the average speed of the fastest and the slowest car. So what we do is, for the fastest car, speed, that's 0.195 divided by 0.00361. That's going to give us 54.01 kilometers per hour. Now, slowest car speed, 0.195 over 0.00166. That's going to give us 117.47 kilometers per hour. So now for the difference, 117.47 minus 54.01, and that's going to give us 63.46 kilometers per hour. Parvisa's Matilda records the distances that 80 different cars can travel with a full tank of fuel. The table shows this information. Write on the class and term that contains the median. So since there are 80 different cars, so median value is going to be half of 80, which is 40. So 7 plus 13 is going to be 20. 20 plus 19 is 39. So that means 40 is going to come in this interval. So that is your median interval. Then says calculate an estimate of the mean. So for the estimate, when you have group data, you first find the midpoint of each of those class intervals. So let's make the midpoint row over here. That's going to be our x value. So midpoint of 250 and 300 is 275. 300 and 400 has 350. 400 to 420 is 410. 420 to 450 is 435. And 450, 500 is 475. So now mean is going to be sigma fx over sigma f. Frequency is your f value. So that's going to be 275 times 7 plus 350 times 13 plus 410 times 19 plus 21 times 435 and plus 20 times 475. All of this is divided by the total frequency, which is 80. So when you solve that, that should give you 32900 divided by 80, and that is 411.25 kilometers. That is your estimate of the mean. The reason why it's called estimate is because we're not using like an exact value. By that, what I mean is that we have like these intervals of value. So let's say in the first interval, it's 250 to 300. We don't know how many, like what value is in that interval. It can be 251, 252, 259, 290, anything. So since we don't know what the exact value is, we just pick the midpoint from each of these intervals and use those to find the mean value. And hence that is why it's called an estimate of the mean, not like an accurate value of the mean. Then it says the histogram is drawn to show the information in the table. The height of the bar for the interval D is greater than 250 but less than equal to 300 is 2.8 centimeters. Calculate the height of the bar for each of the following intervals. So for this, first we need to find the frequency density for each of the intervals. Frequency density has the formula of, so for 300 to 400, it's 13 over 100, which is 0.13. For 400 to 420, it's 19 over 20, which is 0.95. For 420 to 450, it's 21 over 30. That's going to be 0.7. And for 450 to 500, that's going to be 20 over 50, which is 0.4. So they want the height for the intervals 300 to 400, 400 to 420, and 420 to 450. So what we're going to do, there's a formula for this. So if you're trying to find the height of the second column or the class width, your height for the second column would be equal to height of the first column times frequency density of the second column divided by the frequency density of the first column. So this formula is going to change based on which height you're trying to find. If you're trying to find the height of the third column, then you multiply the height of the first column times the frequency density of the third column divided by the frequency density of the first column. So basically what's going to change is this value and this value each time. So by that, what I mean is that if we do it for 300 to 400, that's going to be H1 is 2.8. This is 0.13 divided by this, which is frequency density for that is 0.14. So if you solve this, what you should get is 2.6 centimeters. And I'm going to repeat this step again. But now I'm going to find the third height. So now we're doing H3 and this is going to be FD3. So FD3 is 0.95. So 2.8 times 0.95 divided by 0.14, that's going to give us 19 centimeters. Now for the next one, the 420 to 450, so this has become H4 and it's going to be FD4. H4 is going to be found by multiplying 2.8 to 0.7. And then divide by 0.14 again, and that's going to give us 14 centimeters. So this is how you find the height for each of these intervals. It didn't ask us to find the height of the last bar, so we don't use the 0.4 frequency density. We stop over here. Next part says 2 of the 80 cars are chosen at random. Find the probability that with a full tank of fuel, one of the cars can travel more than 450 kilometers and the other car can travel not more than 300 kilometers. So for this, one of the cars can travel more than 450 kilometers. So that's in the last one. And the other is can travel not more than 300. So that's this 7 over here. So this is our focus. This and this. So that means our probability can be 20/80 times 7/19 plus 7/80 times 79. Now, the reason why it's 20/80 times 7/79 is because if you go back to the question says two of the cars are chosen at random. Find the probability that with a full tank of fuel, one of the cars can travel more than 450 and the other can travel not more than 300. So the one that can travel more than 50 has the probability of 20/8. So we have picked one car. So now there's one less car in the entire 80 cars. So now we have 79 cars. Out of the 79 cars, one of these 7 cars cannot travel more than 300 kilometers. Now, another possibility is that we pick the car that cannot travel more than 300 kilometers first, and then we pick the car that can travel more than 450 kilometers. Hence, first possibility is that we pick the car that travels more than 450 kilometers, and then the car that travels less than 300. Or first you pick the car that travels less than 300, and then the more than 450 one. So this is our probability. And when you solve it, you should get 7/158. Question 5 says P is the 0.17, Q is the 0.5, -5. Find PQ. So to find the vector PQ, we'll subtract OQ and OP, which is going to be 5, -5, -17, and that's 4 and -12. Then it says show that determinant of OP is equal to determinant of OQ. So for that, OP is 1 square plus 7 square, which is going to be square root of 50. And OQ is going to be 5 square plus -5 square. That is also square root of 50. So as you can see, both are equal to each other. Next part says PQ is the chord of a circle with center O. Calculate the circumference of the circle. So if PQ is a chord of a circle with center O, and we have to calculate the circumference of the circle. So if PQ is a chord of a circle and O is the center, that means OP and OQ, which we already found to be equal, are the radius. So we can use square root 50 as our radius value and find the circumference of the circle. So that's going to be, circumference is going to be 2 pi r. So 2 pi times square root of 50, and that is equal to 44.4 centimeter or units. Because I don't think they have given us the units, so 44.4 units. Then PQ is the diameter of a different circle with center R. Find the coordinates of R. So to find the coordinates of R, we use the midpoint formula. Midpoint is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So that's going to be 1 plus 5 over 2 and -5 plus 7 over 2. That's going to give us 3 and 1. That's the midpoint of PQ, or the coordinates of R. Next part says find the equation of the perpendicular bisector of PQ, giving your answer in the form of y equals to mx plus c. So firstly, P had the coordinates of 1, 7. Q had the coordinates of 5, -5. So gradient of PQ is going to be -5 minus 7 over 5 minus 1, which is -12 over 4, and that's -3. When two lines are perpendicular, the product of the gradient equals to -1. So M1 times M2 is going to equal to -1. Let's say this is our M1. So -3 times M2 equals to -1. M2 is going to be -1 over -3, which is 1 over 3. So M2 is the gradient of our perpendicular bisector. Gradient of perpendicular bisector. So next we need the coordinates of the midpoint of PQ because the perpendicular bisector is bisecting the line. So PQ, and this is your R. R is right in the middle of PQ. So coordinates of R we already found the previous part, which are 3, 1. So point R is 3, 1. And M2, which is the gradient of the perpendicular bisector, that's 1 over 3. So we use the point slope form first. Y minus Y1 equals to M times X minus X1. Y minus 1 equals to 1 over 3 times X minus 3. Cross multiply to get the fraction. So 3y minus 3 equals to X minus 3. 3y equals to X. Because minus 3 plus 3 is 0. So y equals to 1 over 3x. That is the equation of the perpendicular bisector. Next part says the position vector of A is A. The position vector of B is B. M is a midpoint on AB such that AM is to MB is 2:3. Find in terms of A and B the position vector of M, giving your answer in its simplest form. So first thing first, let's find AB. AB is going to be B minus A. M is a point on AB such that AM is to MB is 2:3. So AM would be 2/5 of AB. So that's 2/5 of B minus A. MB would be 3/5 of AB. So that's 3/5 of B minus A. It says find in terms of A and B the position vector of M. So position vector of M can be found using either AM or MB. If I use AM, so let's say this is our diagram. Okay, this is O, this is A, this is B. OA was A, OB was B. And M is on AB, where AM is 2:3. So let's say this is M. Okay. AB. We need to find this OM. So to find OM, I'm going to use the root, which is going to go from here to here, and that will give us OM. So that's why I'm going to say OM is OA plus AM. So OA is A, AM is 2/5 of B minus A. Add them up. 5 in the denominator. This is 5A plus 2B minus 2A. So that's 3A plus 2B over 5. That is your position vector of M. Question 6 says the diagram shows the positions of two lighthouses A and B are both seen in a harbor ridge. C is due east of B. So if C is due east of B, let's first make sure that we know that this is a 90-degree angle because it's rightly on the east of B. Next, find the bearing of harbor from both C. So from both C, we have to find the bearing of harbor. It's asking us to find all of this. This is 90. This is also 90. So that means this complete angle, let me take another color. This all is 270. So bearing would be 270 minus 25, and that's going to be 245 degrees. Once again, the main clue is that C is due east of B. Since it's due east of B, that means it's a straight horizontal line, which means this is a 90-degree angle. If this is 90, this is also 90. So this entire angle is 270. We're measuring the bearing in clockwise direction starting from the north. This is our north at C. So this entire angle is 270. Out of this 270, this is 25, and the rest is the bearing that they're asking for. So if we subtract 25 from that 270, that gives us the bearing of the harbor from point C, or both C. Then it says show that the angle CBH is 100. CBH, this angle, is supposed to be 100. So for this, what we can do is that we can just subtract 25 and 55 from 180. So angle CBH would be 180 minus 25 minus 55. That's 180 minus 80, and that's 100. That's your answer. Simple. Then it says show that BH is 3.7 kilometers correct to one decimal place. BH. This. So we know this is 100 degrees. To find this. So for this, we'll use sine rule. Why? Because we have complete set of angle and length. So we can easily use angle C to find length of BH. So 32 over sine 100 equals to BH over sine 25. So 32 times sine 25 divided by sine 100 will give us the length of BH. And that is equal to, as the question says, 13.7 kilometers correct to one decimal place. Then part C says calculate the bearing of A from B. A from B. So this is the bearing that they want. We know that this angle is 100. We do not know this angle. We know this is 90. So for this angle, we already know this length, which was 13.7 kilometers. So whenever we have all three lengths for a non-right angle triangle and trying to find an angle, we use the cosine rule. Cosine rule is also applicable when you have two lengths and the angle between them. So what we're going to do is that we're going to choose the cosine rule over here and try to find angle B. So that's going to be AH square equals to AB square plus BH square minus 2 times AB times BH times cos of angle B. AH is 14 square. This is going to be 11 square, and this is going to be 13.7 square minus 2 times 11 times 13.7 times cos of angle B, which we're trying to find. 9 square minus 11 square minus 13.7 squared. And this is divided by negative 2 times 11 times 13.7, 0.37388. So cos inverse of 0.37388, that is going to give us 68.04 degrees. That is angle B. So now bearing is going to be the sum of 68.04 plus 100 plus the 90, and that is equal to 258.4 degrees. That is your bearing of A from B. Then the next part says at 1 p.m. boat sea sails 32 kilometers directly to the harbor at a speed of 10 knots. Calculate the time when boat sea arrives at the harbor. Give this time correct to the nearest minute. So we have the distance, we have the speed. They want us to convert the speed into kilometers per hour first, and then find the time when boat sea arrives at the harbor. So 1 knot is 1.852 kilometers per hour. So speed in kilometers per hour is going to be 10 times 1.852 first, which is 18.52 kilometers per hour. After that, we're going to find the time taken. So time taken is going to be distance, which is 32 divided by the speed, 18.5. And that is going to give us 1.73 hours. So 1.73 hours in minutes is basically 1.103.8 minutes. We multiply 1.73 by 60, which is approximately equal to 104 minutes. So we have to give this time correct to the nearest minute. So at 1 p.m. boat sea sails. So 104 minutes, when you divide that, that's 1 hour, 44 minutes. So 1 p.m. plus 144, that's 244. So 244 is the time at which boat sea arrives at the harbor. PM. Then it says calculate the distance of boat sea to the harbor when boat sea is at the shortest distance from lighthouse B. So that's basically this distance. Shortest distance is the perpendicular distance. Always. So what we can do is, I know this was 13.7, if I'm not wrong. Yeah. So you can use SOHCAHTOA to find this length. So using SOHCAHTOA, we can find this shortest distance of B from the harbor, from this point, sorry. So what we can do is, we have the hypotenuse, we have the angle, we have to find this. So we'll use, wait, sorry, 1 second. We have to find calculate the distance of boat sea to the harbor when boat seas are the shortest distance from lighthouse B. Yeah, so we need to find this length. This is the unknown length, CH. So we have the hypotenuse, we have the angle, CH is the adjacent, so we'll use cos of 55 equals to CH or X over 13.7. So 13.7 times cos 55. And that is going to give us 7.86 as the shortest distance between C and H, or like shortest distance because of 7.86 is the value of CH kilometers. Question 7 says the diagram shows a box in the shape of a cuboid. The box is open at the top. Work out the surface area of the inside of the open box. So since the top is open, we'll include the 70 times 30 area once. So surface area is going to be 70 times 30 plus 2 times 30 times 40 plus 2 times 40 times 70. And that is going to give us 10,100 centimeter square. Then it says cylinders with height 20 centimeter and diameter 15 centimeter are placed in the box. Work out the maximum number of these cylinders that can completely fit inside the box. So what we will do is that the diameter is 15 and height is 20. Diameter 15, height is 20. So the horizontal length is 30 and the vertical length is 40. We know 40 and 20 are basically multiples of 2. So 40 divided by 20 is 2. And 30 divided by 15 is also 2. So that means we can make 2 columns and 2 rows of the cylinders. So if we put 1, 2, that's what's it called? 70 is the length over here. So 15, 70 divided by 15, that's going to give us 4. So we put 4 over here and then another 4 over here. So this is the maximum number of cylinders that we can put. Because 70 divided by 15 gives us 4.6 recurring. So obviously we can't put like a decimal of a cylinder. So it's going to be 4 whole cylinders at the bottom and then 4 more at the top. So 2 rows, 2 columns. So there's going to be another line after that. So there's this line and there's another at the back. So that's going to be another 1, 2, 3, 4. 1, 2, 3, 4. So in total, we have 16. So 16 is the maximum number of cylinders that we can fit inside the box. Then the next part says, a solid bronze cone has a mass of 750 grams. The density of the bronze is 8.9 grams centimeter cube. The radius of cone is to height of cone is 1:3. Show that the radius of the cone is 2.98 centimeters correct to 3 significant figures. Density equals to mass or volume. And the volume of a cone with radius r and height is v equals to 103 pi r square h. So first, we're going to begin with finding the volume. Volume equals to density equals to mass over density. So that's 750 divided by 8.9. And that's going to give us 84.27 centimeter cube. Now this is the volume of the cone. Volume of cone. We know that the ratio of the radius of the cone is to height of the cone is 1:3. So if R is the radius, 3R is your height. Let's assign variables to it because we're trying to find the radius, which is 2.99. So 84.27 is basically equal to 1/3 pi R square times 3R. Because the ratio of radius of the cone is to height of the cone is 1:3. So it's R is to 3R. So R squared times 3R. 84.27 divided by pi equals to R cubed because the 3's get cancelled out. So that's going to be 26.82 equals to R cubed. Take the cube root on both sides, and that's going to give us 2.99 centimeters as our radius. Then it says calculate the total surface area of the cone. The curved surface area of a cone with radius r and slant height L is equals to pi RL. So total surface area of the cone is pi RL plus pi R squared. We need to find the value of L. This is L, this is height, this is R. So R was 2.99. Since height is thrice of R, so 3 times 2.99, which is going to give us 8.97. That is the height. So now, using Pythagoras, we find L. So L square equals to 8.97 square plus 2.99 square. L equals to square root of 89.401. And that's going to give us 9.46 centimeters. So total surface area is going to be pi times 2.99 times 9.46 plus pi times 2.99 squared. You solve that, and what you get is 116.95 centimeter squared. That's your answer. Question 8 says on the axis, sketch the graph of y equals to x squared plus 7x minus 18. On your sketch, write the values where the graph meets the x-axis and the y-axis. So for the y-axis, you put x equals to 0. And for the x-axis, you put y equals to 0. Let's start with the y-intercepts. So when you put x equals to 0, we'll have y equals to 0 squared plus 7 times 0 minus 18. So y is negative 18. So let's call this point A, 0, negative 18. Then you put y equals to 0. So 0 equals to x squared plus 7x minus 18. Factors of 18 are 9 and 2, 6 and 3 as well, 18 and 1 as well. But we're going to choose 9 and 2 because 9 minus 2 is 7. So x squared plus 9x minus 2x minus 18. 0 equals to x bracket x plus 9. You're factoring by grouping. So you factored the first two terms separately and the last two terms separately. And negative 2 common over here. So x plus 9 again. X plus 9 is common between x and negative 2. So 0 equals to x plus 9 times x minus 2. So x equals to negative 9, x equals to positive 2. So point B is 2, 0, and C is negative 9, 0. And what else do we need? We can find the line of symmetry as well, which is going to be x equals to negative b over 2a. B is 7. So negative 7 over 2 times 1. So negative 7 divided by 2, that's negative 3.5. That is your line of symmetry. So what we're going to do over here is that I'm going to sketch these now. So scroll down, remove this extra working. 0, negative 18. So let's say that's over here. Negative 9, let's call that over here. Positive 2, let's call that over here. Something like this. Like, I know my graph looks ugly, but like, it's like the shape is going to be similar. Like, it's going to be a minimum curve like this. I don't think we need the line of symmetry because they didn't specify it, so you can skip that. You just mention your x-intercepts and y-intercepts, and that's your answer. Then it says find the derivative of y equals to x squared minus 3x minus 28. So when you differentiate this, x squared will become 2x. You bring the power down and then subtract 1 from the power. So when 2 comes down, 2 minus 1 is 1. Negative 3 is going to be negative 3 because 1 minus 1 is 0. So any variable to the power of 0 is 1. And the derivative of constant is always 0. So 2x minus 3 is your derivative. Find the coordinates of the turning point of y equals to x squared minus 3x minus 28. So for the turning point, you put your derivative equal to 0. So 0 equals to 2x minus 3. 3 over 2 is x. Y is going to be 3 over 2 squared minus 3 times 3 over 2 minus 28. 9 over 4 minus 9 over 2 minus 28. This is negative 121 over 4. So 3 by 2, negative 121 over 4. That's your turning point. What sees that the line y equals to 5 minus 2x intersects the graph of y equals to x squared minus 3x minus 28 at point P and point Q. Find the coordinates of P and Q. You must draw your working, give your answers correct to 2 decimal places, which means we'll be using the quadratic formula. So since they're intersecting, we can put the two equations equal to each other because they share the same x and y value. 5 minus 2x equals to x squared minus 3x minus 28. Select all the terms on one side. So 0 is x squared minus 3x plus 2x minus 28 minus 5. X squared minus x minus 33. Now we put this in the quadratic formula. X equals to minus b plus minus square root of b squared minus 4ac over 2a. A is 1, b is negative 1, and c is negative 33. Negative minus 1 plus minus square root of negative 1 squared minus 4 times 1 times negative 33 over 2 times 1. And that is going to give us 1 plus minus 11.53 over 2. 1 is x plus 11.53 over 2, which equals 6.265, which is 6.27. And the other is 1 minus 11.53 over 2, which is negative 5.265. to 7. These are the two values of x, correct to two decimal places. They want the coordinates of P and Q, so we substitute these back into the equations. I'm going to pick the line equation because that's going to be easier to solve. So let's remove this. So y equals to 5 minus 2 times 6.27. And that is giving us negative 7.54. And y equals to 5 minus 2 times negative 5.27. And that's giving us 15.54. So P is 6.27 and negative 7.54. And Q is negative 5.27 and 15.54. These are the coordinates of P and Q. Question 9 says we have three different functions. First, we have to find the value of f of 3. Easy, f of 3 equals to 4 times 3 plus 1, 13. G of f of 3, so we're going to put the value of f of 3 in G function. That's going to be G of 13 because f of 3 is 13. So 6 minus 2 times 13. 6 minus 26, that's negative 20. Find the inverse of G. So you put G of x equals to y, so y equals to 6 minus 2x. Right now, y is the subject of the equation. You will make x the subject. So it's going to be 2x equals to 6 minus y. X equals to 6 minus y over 2. Now, the reason why I swapped 2x and y in the first step is because I want to make sure that the variable that I'm making the subject, that variable is positive, because that's going to make my calculation easier. So I immediately swap 2x with y. It's not, x is positive. 6 minus y is on one side, divided by 2. X equals 6 minus y over 2. So now replace x with g inverse of x and y with x. So 6 minus x over 2 is your inverse. Find x with f of x equals to g of 2x minus 7. So we know that g of x is basically equal to 6 minus 2x. So g of 2x minus 7 would be 6 minus 2 times 2x minus 7. That's 6 minus 4x plus 14. And that's 20 minus 4x. That is g of 2x minus 7. So this they're saying is equal to f of x. F of x was 4x plus 1. So 4x plus 1 equals to 20 minus 4x. 4x plus 4x equals to 20 minus 1. 8x equals to 19. X equals to 19 over 8. That's your answer. Then it's asking find the value of h of h2. Now, h of x is 3 to the power of x minus 2. So h of 2 first is going to be 3 to the power of 2 minus 2, 3 to the power of 0, which is 1. So now that's going to be h of 1. So that's 3 to the power of 1 minus 2. That's 3 to the power of negative 1, and that's 1 over 3. So 1 over 3 is your answer. Then find x when h inverse is equal to 10. So to find h inverse, first you put the function equal to y. Now we take logs on both sides. We'll bring x minus 2 to the power down. This is 3. So now we divide log of y by log of 3, which equals to x minus 2. Next, we take 2 to the other side. So we have log of y divided by log of 3 plus 2 equals to x. Now we can see that x is subject instead of y. So we can replace this by h inverse of x, which is log x, sorry. Now log x over log 3 plus 2. They're saying find x when h inverse of x equals to 10. So 10 equals to this basically. So for this, I'm going to remove this side now. So that's going to be 10 minus 2 equals to log of x over log of 3. Eight equals to log x over log of 3. Cross multiply. 8 times log of 3 equals to log of x. Bring 8 to the power, log 3 to the power of 8. Cancel out the logs. 3 to the power of 8 equals to x, which is 6,561. That is your value of x.